Hello students. In my last video, we have discussed the motion of the block on an inclined wedge, and we have calculated the acceleration of the wedge in using inertial frame. Okay, and now in this video, I am going to calculate the acceleration of wedge as well as the acceleration of the block with respect to the non-inertial frame. Non-inertial frame means this block is moving because this particle of block is sliding, and because of this sliding of this particle, this wedge is also accelerating in the minus x direction. Okay, so let us solve this problem. So let us say this is my x-axis and this is my y-axis. Now, so because this block is over the wedge, so this is so wedge is also applying a normal force perpendicular to it. Similarly, this block is also applying a reaction force which is equal to n also. And now we can find the component of this n. So the component of this n is n sine theta. So block which is in the direction of the movement of the block. So I can say that the acceleration of the block or force on the block is MAW, and which should be equal to the n sine theta. So this is applying force and this block is moving. So I say this is my equation number 1. Now coming back to the block, if I see the x component of this block, which is AX. Now I'm saying the acceleration is like this. This is my x-axis, this is my y-axis, and this is my acceleration. This is my theta. So my AX, the component will be A cos theta, and my AY will be minus A sine theta. So my AX, MAX, which is equal to MA cos theta, will be equal to, so in the x direction I'm writing the equation in the plus x direction. So in the x direction the force component is n sine theta. Now in this problem, because this wedge is moving in the minus x direction, so there will be a pseudo force which will be equal in opposite sign. So here there will be acceleration. So the acceleration of block will be in x direction. Also we have to consider, so the force on the block also will be mass multiplied by the acceleration. This acceleration is because of this force. This term is because of pseudo force. So now let us solve. Now let us solve for AY. So in the AY direction, y direction, we have a n cos theta, and in minus direction we have this mg. So say this is equation number 1, this is equation number 2, and this is equation number 3. And now MAY is what? Minus A sine theta. So I can write minus A sine theta is equal to n cos theta minus mg, and I say this is my equation number 3. So now we have written all the equation. Now we have to solve this equation 1 and 2 and 3, and we have to find the AW and A. So let us do it. Now I can write the equation number 2. I have m a cos of theta, which is equal to n sine theta. N sine theta value I can put from this equation. So this gives me m a w plus m small m a w. So this gives me m a cos theta. I can take this a w or acceleration of wedge common. So say this is my equation number 4. Now I have a AW, and similarly I have here say MA sine theta, which is equal to mg minus n cos of theta. Now again, I can replace this n here and cos n here with this equation. So this equation will be also m a sine theta will be mg minus capital M a w upon sine theta cos theta become cot theta. Okay, this is my equation number 5. Now let us solve this equation. Let us solve these two equations. So I have ma cos theta. So I can divide these two equations. So what it will give me? Ma will be cancelled. This will be simply cot theta. And this will be what? M plus M. This will be mg minus m cot of theta. And if I solve it further, this will give me what? This will give me mg cot theta minus m aw cot square theta is equal to m plus m acceleration of wedge. Now let it solve it further. So if I solve it further, this gives me what? This gives me say I want to write a omega. So this will be your mg cot theta, and this will become m plus m acceleration of wedge plus m, this will be cot square theta. Now let us solve this one. So this gives me acceleration of wedge is equal to mg cos theta upon sine theta upon m plus m cos square theta upon sine square theta. And if I solve this one, this gives me mg sine theta, sine will be cancelled, cos theta, and here this will be m sine square, m cos square will give me m plus m sine square theta. So this is the same expression what we have got in my last video. So now we have the acceleration of wedge, which is equal to mg sine theta cos theta upon m plus m sine square theta. Okay. Now you have to find the acceleration a. So this a will be, acceleration of block will be m plus m from this equation upon m cos theta acceleration of wedge. So if I solve this one, this gives me m plus m g sine theta m plus m sine square theta. So this is the acceleration of block with respect to wedge. Now if I want to find the acceleration of block with respect to the inertial frame, so I told you the acceleration of the block is equal to acceleration of block with respect to the wedge plus acceleration of the wedge. I can use this equation and I can find the acceleration of the block in an inertial frame. Okay, hope you like the solution. Thank you very much.